In this video, we're going to take a look at the definition of a relation and a function and see if we can determine if something is a function when given in various formats. So the first thing is a relation is just a relationship or correspondence between two sets of data. We're going to call the first set the domain and the second set the range. If we think in terms of our ordered pairs, x's go with the domain or are the domain, and the range is the y values. The only requirement here is that everything in that first set gets paired up with something, at least one thing in that second set. So every x is paired up at least once. If I want to talk about a function, I'm going to restrict that a little bit and say that we still have that relationship, we still have a relation, but in this case, every member of the domain corresponds to exactly one member of the range. So once I've used my x value and paired it up with a y, I can't reuse it. Okay, so it's important every single function is also a relation, but the opposite is not true. Let's take a look at an example. So right here I have what I call a mapping that's showing how this first set, this -6, 6, -3, 3, 0, this domain gets paired up and related to the second set, 36, 9, and 0, which is my range, right? So first set is domain, second set is range. It's just showing visually how to pair them up. Probably you're more familiar with this listing form. So all I did is I took the element from the first set and what it was paired with, and that's my first ordered pair. Second number and its pairing, second ordered pair, and so on. The question is this a function? Well, the definition says that once I use an element over here in the domain, I can't reuse it. It is true that two different elements in the domain got sent to the same range element, but once I use -6 over here from the domain, I didn't reuse it. So there's no repeat from the domain, no repeat of the x, then it qualifies as a function. So I want to point out that the y's did get repeated. That's okay, as long as the x's are not repeated. Okay, so there is a way to visually tell if something's a function as well, because if I repeat an x value with two different y's, I get a vertical line. So if it's possible for a vertical line to cross a graph more than once, then that graph is not going to be a function. Okay, so let's look at a few examples here. So this first one, I have a nice parabola. No matter where I would draw a vertical line, it's only going to cross that one time. So each vertical line represents an x value, and it's only going to hit once. It's only going to get paired with one y value. This next one, it's what we call a discrete function because it's isolated individual little points rather than a nice connected picture. And once again, no matter where we draw a vertical line, it's only going to hit one of those dots. So every single x gets a different y value, or at least, gets only one y value. But then I come to this third picture, and you see this red line here, it hits the graph twice. So this particular x value of -4 is paired up with a positive 4 value and a negative, whatever that would be, maybe -6 value. So it has two different y's for that same x. So that one is not going to be a function. A few more examples. Another discrete one, but this time I have 2 points that are above one another. So that is not a function. This next one is what we call a piecewise function or a piecewise defined relation because I have different rules for different x's. The problem is not that it's broken. The problem is that when I draw this vertical line here, it actually lands on both pieces, telling me again that that particular x has two y values. So that's not a function. And then here, this cool looking triangle, nice picture, but it is not a function because that vertical line crosses more than once. It's good to have that in the back of your head because sometimes they give us an equation and ask us, is this a function? So if you're given an equation and asked to determine if it's a function, you can solve it for y and see what you get. So in this particular one, I added the 2y, subtracted the 6, and got my equation in y. So that means when I put an x value in, there's only one possible answer for that y. That's it. This one, the second one, 4x plus y squared equals 2, if I solve for the y, I first subtract 4x, then I take the square root of both sides. But you should remember that when I take the square root, I get both a positive and a negative root, so I put this little plus minus here. So now if I put a number in here for x, then I'm going to get a square root of something, and the y could either be the positive of that or the negative of that. So for a particular x, I could get 2y values, so this one is actually not a function. I went ahead and put both of these in a graphing calculator, and you can see that this first one would pass the vertical line test, so that confirms what we see with the equation. This second one over here, if I grab a marker, you would see that nope, right there it's going to cross 2 times, so this one is not a function. Let me know if you have any questions.